Hi scientists, it's Ariana
and Alyssa,
and welcome back to another Demo of the Week.
Today we're going to be talking about electrons. Electrons are negatively charged subatomic particles.
And electrons' unique properties allow it to act as both a wave and a particle.
Wait, how can something act as both a wave and a particle?
Well, you see, when an object like an electron has really high energy but low mass, it experiences wave-particle duality regarding its characteristics.
Oh, okay. Let's look at some examples to show this fact. So here we have a cathode ray tube, which is essentially a vacuum. And when we attach these electrodes on either side, a stream of electrons will go through.
When we turn on the power, electrons shoot through the tube in a concentrated stream that we'll be able to visualize.
So this green light is a stream of electrons. We can see the path of the electron beam because the electrons excite the phosphor coating inside the tube, causing them to glow green.
Wait, but how do we know that these are electrons and not just normal light particles?
Well, we can use our handy-dandy magnet to show that.
So photons, the particles which make up all light sources, are not charged in any way. However, since the light beam is moving away from the positive end of your magnet, that must mean the beam is negatively charged, which confirms it's electrons that we see shooting through the tube.
Correct. So this is an example of how electrons can act like waves.
But what about when they act like particles?
So here we have a pinwheel device. And when we attach the electrodes, we'll be completing the circuit.
Just like any other circuit, electrons will flow away from the negative end of the battery, go through the pinwheel, and come out the positive side.
Okay, let's turn this on and see what happens. I can see the pinwheels moving, but how are electrons acting like waves?
Well, when waves encounter a solid object, they experience transmission through said object and can come out the other side.
Oh, so when you knock, the sound waves go through to the other side, but the door itself doesn't move. However, if you push the door with your hand, it moves, just like the electrons pushing the pinwheel.
Exactly.
Okay, so in this case, electrons are showing us how they act like particles, because they cannot transmit through the pinwheel, but instead have to transfer kinetic energy in order to push the blade and get to the wire on the other side to complete the circuit.
All right, scientists, thanks for watching.
We'll see you guys next time for another Demo of the Week.
Bye!